The topic for my today presentation is Introduction to Linear Regression. The goals of these lectures are learning how and when to apply linear regression as a supervised machine learning approach to develop prediction models. The second goal is to understand the implementation of simple linear regression using least square regression models. The third goal is to learn how to implement linear regression using the sklearn in Python. The outlines of the lectures are understanding linear regression, assumption that must need to hold before applying the linear regression. Then we will talk in more detail about the simple linear regression as an example. And we will talk about the implementation of the simple linear regression using the least square regression method. And lastly, we will talk about the regressions with variety of computer programs. So let's talk about the linear regression in more detail. It is actually a supervised machine learning approach for developing prediction models, and it assumes that the dependence of y on x1, x2 to xp is linear. So ideally, the regression models are linear as shown by the blue line, but in many real situations, the regression functions are almost never linear as shown by the red line. Although regression is overly simplistic, but it is extremely useful both conceptually and practically. And linear regression is about predicting the dependent variables based on the independent variable. And in case of one predictor variables, it is called simple linear regression. In case of multiple predictor variable, it is called multiple linear regression. So in this presentation, we will keep our discussion limited to the simple linear regression, and we'll talk about it in more detail. So these are just some assumptions that must hold before deciding whether to apply linear regression to solve a prediction problem. So the first thing is we need to draw the scatter plot that find the correlation coefficients to find out whether there exists a strong relationship or correlation between the dependent and independent variables. So down here, it's a scatter plot where the dots represents the data points. As we see that there's a linear, the data points shows a linear trend around the red line, which shows that there is a strong relationship between the dependent and dependent variables, and hence we can apply the linear regression to solve this prediction problem. The second assumption that we need to check is whether the data is coming from the continuous variable like the time, like the sales, like the weight. The third assumption that we need to check is whether the data observation are independent from each other or not. And the last one is whether the data has any significant outliers. So if all these conditions are true, the data coming from the continuous variable, the observations are independent from each other, the data doesn't have any significant outliers, and the relationship between the dependent and dependent variable is linear, then the best solution is to solve this problem using the linear regression. As I talked previously that in this presentation, we're going to keep our discussion limited to the simple linear regression. So in case of single predictor variable x, the regression is called simple linear regression. Assume there is only one predictor x, then the linear model would look like y is equal to b plus mx plus the error term. So where b is the intercept term, and it is the expected value of y when x is equal to 0. M is the slope term, and it is an average increase in y associated with a unit increase in x. Before we move on, let's talk about the error term in more detail. So in the linear model, y is equal to b plus mx plus epsilon. The error term means that the actual y differ from the predicted y in the model during its real world implementation. So in many situations, the predicted value using the developed model would be different from the expected one. And that's because of this error term. So the true relationship is probably not linear because of this error term. And there may be other variables that causes variation in y. There may be measurement error, of course. So there are some mathematical assumptions about the error term. It is independent of the observations, and its mean is 0. And error of each observations are uncorrelated and they have a common variance. So in most of the real-world situations, this error term is considered to be negligibly small, and hence the approximated model is represented as y is equal to b plus mx. And that's why most of the models would not be strictly linear, but they will be approximately linear because we ignore this error term. So one way to implement simple linear regression is least square method, which we're going to talk about in more detail. So with given data points x and y, the goal is to find a line that best fit to them. This figure shows 5 data points, and the vertical deviations of those data points from the fitted line are called errors. So the goal of solving the least square regression method is to find the slope and intercept of this line in such a way that the sum of the squares of these errors would be the minimum possible value. So to achieve these goals, we need to implement the least square regression method in these 5 steps. The first step is to find the square of x in the product of x and y. And then we need to sum up all the values of x, y, x squared, and the product of x and y, which gives us sigma x, sigma y, sigma x squared, and sigma xy. Then the next step is to calculate the slope using the expression 1, where n is the number of data points. The fourth step is to calculate the intercept using the expression 2. And the last step is to put the intercept and slope into the expression y is equal to mx plus b. So let's consider practical examples to deeply understand the implementation of least square regression. So this table shows the hours of sunshine versus the ice cream sold at a shop from Monday to Friday. So on Monday, the hours of sunshine is 2 hours, while the ice cream sold was 4. So here in this table, we have not represented any unit, whether this is 4 ice cream or 4 kg ice cream or what. The second, on Tuesday, so the number of the hours of sunshine was 3, while the ice cream sold was 5. So now the goal is to develop a model based on this training data set that can be used to predict the future. For example, in the future, a different day, there will be different hours of sunshine. And that's why there will be a different demand of the ice cream that is sold out at the shop. So we need to come up with a model that can predict the number of ice cream that could be sold out at a particular day based on the hours of the sunshine at that particular day. So the first step is we need to find the square of the hours of sunshine that is represented by x. Then we need to find the product of the hours of sunshine in the ice cream, which is xy, shown in this column. Then to find the slope and intercept, we need to sum up all the values of x, sum all the values of y, sum all the values of x squared, sum all the values of x and y, which are shown in the final row of this table. Here we need to put the values, the calculated in the previous table shown in its last row into the expression of slope and intercept, which result into m is equal to 1.51 and intercept b is equal to 0.304. By putting these values into the expression of the line y is equal to mx plus b, where y is the ice cream sold in a particular day, m is the slope that is find out here, which is 1.518, and x is the hours of sunshine at a particular day, while 305 is the intercept of the line. So which will result into this expression: ice cream sold is equal to 1.58 times the hours of sunshine plus 0.305. This is actually an expression that can be used to predict the future. So if you want to predict for a particular day with some hours of sunshine that how much ice cream will be sold out, this expression can be used to predict it. So this is an example how the least square regression can be used to come up with a model, to come up with an expression that can be used to predict the future. So lastly, we are going to talk about the regression with a variety of computer programs. So linear regression can be very easily implemented using R programming, using MATLAB, using sklearn, and using Python, using Excel. This is an example of implementing the linear regression using the sklearn and Python for the data set that was shown in the previous table, where this x is the number of sunshine hours at a particular day, while the y is the ice cream sold out at those days. So this is the Python code using the sklearn library to implement the linear regression model. So this is all for today. Thanks for watching.